professor in Department of Computer Science Engineering, Akgec Engineering College, Jayaswal. Here I am going to take lecture on computer organization and architecture, and this is the first lecture, so I am going to cover the introduction part of the computer organization and architecture. If we talk about the computer organization and architecture, here there are two terms. First is computer organization and second is computer architecture. So first we are going to cover the computer organization part. Then if we talk about the computer organization, then it is a design of the components and functional blocks using which computer systems are built. The analogy of the computer organization is like a civil engineering task during building construction that requires cement, bricks, iron rods, and other building materials. If we talk about the computer architecture, then it is how to integrate the components to build a computer system to achieve a desired level of performance. The analogy of the computer architecture is architect's task during the planning of the building, that is overall layout, floor plan, etc. The architecture of computer is classified into two categories. First one is von Neumann architecture and second is Harvard architecture. If we talk about the von Neumann architecture, in von Neumann architecture we use only single memory for both instruction and data that runs the program. Instruction or data are stored in the same memory in case of von Neumann architecture, and the disadvantage of the von Neumann architecture is that is processor and memory bus act as a bottleneck. This is the main disadvantage of the von Neumann architecture. This is the von Neumann architecture. Here we can see that there is a processor and there is a one single memory that is called program and data memory, in which we store data and program in the same memory. And we can see that there is only one single bus that is connected to processor and memory. So at one time, processor can access either program or data. Processor cannot access simultaneously data and program. In Harvard architecture, if we talk about the Harvard architecture stores the machine instructions and data in separate memory units and that are connected to a different buses. Separate memory for program and data, and instructions are stored in program memory and data are stored in separate memory. Instruction and data access can be done in parallel. This is the architecture of Harvard architecture, in which we can see that there is a processor and for instruction there is a separate memory that is called program memory, and there is another memory that is called data memory, in which there is a data can be reside. And here we can see that processor is connected to the program memory with different bus and processor is connected to the data memory with the different bus. In this scenario, processor can simultaneously access the instruction from the program memory and data from the main memory. This is the architecture of the Harvard. Next, we talk about the digital computer. This is also a basic part. If we talk about the digital computer, is a digital system that performs the various computational tasks. Digital computer uses the binary number system, which has digits 0 and 1, and binary digits is called a bit. If we talk about the computer system, it is divided into two functional entities, that is hardware and software. Hardware means electronic and electromechanical devices, it is called hardware, and software means it consists of instruction and data. The hardware of the computer is usually divided into three categories, that is CPU, memory, input-output, processor, that is IO. This is a block diagram of digital computer in which this is the input device, this is the output device. Here we can see that there is a one separate processor for the managing the input and output devices. That is called IUP, means input output processor. In between there is a central processing unit, that is a core part of the computer. It is also called the brain of the computer. And this is the random access memory by which we can perform the several operations in the computer. So it is a block diagram of digital computer. Next is communication between memory and processor. Basically, memory and processor are communicating with each other. So this is the architecture by which we can see that memory and processor will communicate through the three buses. First is address bus, second is data bus, third is control bus or control signal. And in processor, there are two main registers are used for this communication. First is MAR, means memory address register, and second is MDR, that is memory data register. Memory address register is connected to the address bus and it is in unidirectional form. And MDR, that is memory data register, is connected to the data bus and it is of bidirectional. And there is one important bus that is called control bus or control signal, that is coming from the processor, but basically it is coming from the control unit, because we know that there is a control unit that can generate the control signal for overall operation in the computer system. So control unit generate the control signal and control unit reside in the processor side. So these signals are created from the control unit and goes to the primary memory. And in this case, we can also see that if we talk about the read and write operation, basically memory performs read and write operation. Then we can, if we talk about the read operation, then data flow from the memory to processor. If we talk about the read operation, then data flow is from the memory to processor. If we talk about the write operation, then data flow from the processor to memory in that case. Next is functional unit of digital computer. Basically, computer system consists of 5 functionally independent main parts, that is input, memory, arithmetic and logic unit, output, control unit. These are the functional independent main part. Here we can see that there are the 5 independent units, that is input, output, memory, ALU, that is arithmetic and logic unit, that is next is control unit. And the combination of arithmetic and logic and control unit is called processor. And input output is combined in one form, that is called I by O. So here we can see that there are 5 independent units: input output, memory, arithmetic and logic and control. But we can see that there is a 3 main parts. 5 independent units, but we can see that there are 3 main parts. First is I by O module, next is memory module, and third is processor module. Next, that is interconnection structure. A computer system consists of a set of components or more 3 basic types, that is processor, memory and I by O, that communicate with each other. Thus, there must be a path for connecting the module. The collection of paths connecting the various modules is called interconnection structure. In this case, we are going to discuss the memory module. And in memory module, a memory module will consist of n words of equal length, and each word is assigned a unique numerical address from 0 to n minus 1. Here we can see that there is a memory module, and in memory there are only two operations performed. First is read operation and second one is write operation. For reading and writing, there is the requirement of two buses. First is address bus, second is data bus. And data bus is of bidirectional because if you perform read operation, then data flow from the memory to processor. If you perform write operation, then data flow from the processor to memory. So data bus should be in bidirectional form. So here we can see that here is incoming data bus and this is the outgoing data bus. We can also see that there is a n words in memory of equal length. These n words of equal length, if we can see that if there are 8 words in first 0 address with the corresponding of 0 address, if there are 8 words, then corresponding of n minus 1, there should be 8 words because the length of the words is equal in each case. Next is I by U module. From the internal point of view, I by U module is functionally similar to memory because in memory there are two operations performed, that is read and write, and here in I by U module there is only two operations performed, that is read and write. So we can say that the internal point of view, I by U module is functionally similar to memory. Here there is a diagram of I by U module. Here we can also see that there is a read and write line. It is also used in memory module. Here used data address bus, and here we use two separate data buses, that is internal data and external data. If you are going to take input from the main memory, or we can see that random access memory, then we can say internal data bus. Or if we take input from the keyboard, then we can see that this is the external data bus. Similar for, we can say that internal data or external data. Here in I by U module there are M port. Basically in I by U module we are dealing with basically input and output devices. So for to connect the I by U devices to the computer system, we require the ports. With the help of ports, we connecting the component of input and output devices to the computer system. So there is a requirement of ports by which we can connect it to the processor. Next is interrupt signal. Basically, we are having three modules: memory module, I by U module, and processor module. But there is only one module that can generate the interrupt signal, that is a I by U module. I by U module can generate the interrupt signal, and this interrupt signal is propagated to the processor. Next is we are going to talk about the processor. The processor reads in instruction and data, writes out data after processing, and uses control signal to control the overall operation of the system. It also receives the interrupt signal that is coming from the I by U module. This is the general architecture of the processor. This is the CPU, that is central processing unit. In CPU, I by U module. This address bus is required, data bus is required, and control signal that is generated from the control unit. If we talk about the processor, the interconnection structure must be support the following transfer, that is memory to processor, processor to memory, I/O to processor, and processor to I/O, and last is I/O to or from memory. Next is bus interconnection. A bus is a communication pathway connecting two or more devices. A bus that connects the major computer components, that is processor, memory, and I/O, that is called the system bus. If you talk about the bus structure, a system bus consists of from about 50 to 100 separate lines, and each line assigned a particular meaning or function. There are three buses are used in bus, that is of data lines or data bus, address line or address bus, control line and or control bus. If we talk about the bus structure, here we can see that there are three main components: CPU, memory. These are the part of the memory, and this is the I/O module. And these three components, CPU, memory, and I/O, connecting with the help of data lines, address line, and control line. Because these are the system bus that are connecting to CPU, memory, and I/O. If we talk about the typical control lines, these are the some typical control lines, that is memory read, memory write, I/O read, I/O write, transfer ACK. If we talk about the transfer ACK, it means that if processor accepts data from the I/O devices, then it can transfer the acknowledgement. Basically, ACK means acknowledgement. Bus request, if I/O devices wants buses, then I/O devices generate bus request. Bus grant is given by the processor. Interrupt request generated by the I/O module. Interrupt ACK given by the processor. Clock basically used to synchronize the all the operation in the computer system. And reset is used to reset the operation. If you talk about the bus architecture, in bus architecture there is two types of bus architecture: single bus architecture and multi-bus architecture. Single bus architecture, only one data transfer allowed in one clock cycle. Here we can see that processor, memory, input and output are connected to the single bus. So here we can see that there is only one data transfer is allowed in one clock cycle. If you want to try transfer another data in single clock cycle, then data is garbage. In multi-bus architecture, for multi-bus architecture, parallelism in data transfer is allowed, because here we can see that processor and memory are connected to the different bus, and IOP, that means input output processor, is connected to the different bus. Here parallelism is allowed for the data